Hello all. In this video, we are going to solve question number 4 in arrays and pointers and functions section in JNTU R18 C language syllabus. For that, what I did was I copy pasted the program or the problem in my VS Code and created a file called factorial.c. Let's start writing the code. So the basics of C programming language, like main function, printf, scanf. I made a separate video. I'm going to leave that link, video link in the description. So I highly encourage you to go and watch the video before start hitting or learning these programs. Okay. So basically, this is to find the factorial of a given number, and factorial is nothing but if I give 5, it should be like 5 into 4 into 3 into 2 into 1. Okay, so it's like if I give n, then it would be n into n minus 1 into n minus 2, okay, and into n minus, okay, n minus 3, and it will go on till n minus 1. So if you expand this, basically n minus 1, it would be like n minus n plus 1. So n minus n 0, it's going to be 1. So till 1, okay, you're going to actually expand this 5 into 4 into 3 into 1. I give 10, 9 into 8 into 7 into 6 into 5 into 4 into 3 into 1. Okay, so it's very straightforward. We can clearly understand that all we have to do is take a variable while loop while n is greater than 0 till, because we have to reach till 1, right? 0, if something is multiplied with 0, obviously it's going to be 0, so we are not supposed to take 0. So I am going to take int n, and I'll ask the user to enter n for which you want to find factorial. Okay, and then I'm going to give scanf %id and %n, and then here what I'm supposed to do is I'm going to take a variable called int fact, and I'll give it as 1, and fact is equal to fact into, so n and n minus minus. So every time what's happening, if I give 5, so it's going to be 5 into 1, so it's going to be 5, and next time my n will be decremented, so it's going to be 4, 3, 2. The moment it reaches 0, it will exit, so it will run, n will reach till 1. So my logic looks good. And finally, once this loop is done, what I'm supposed to do is I'm supposed to print the factorial of %id is %d. Okay, I'm going to give new line, and what's the factorial? First one is n, next one will be fact. So let's try to debug on our own, and we'll check it out. Okay, let's take the same example. If my n is equal to 5, so is 5 greater than 0? Obviously it's true. So as it is true, it will come into the loop, and it's going to be fact, means nothing but 1 into n, that is 5. So my result would be 5. And now what happens, my n would be, my n minus I've given, right? My n would be 4, and 4 greater than 0, that's true. And previously my fact has 5 here, so 5 into 4 is equal to 20. And same thing I'm going to give n equal to 3. Now is 3 greater than 0? Absolutely. And here previously my fact has 20, now it is 3, 23 is 60. Perfecto. And now I'll give n equal to 4 greater than 0, which is true. Previously it is 60, so 60 into 4 is nothing but 6 was 24. Previously, oh, it's not 4, we are incrementing. Okay, we are supposed to decrement. So 60 into 2, it's 120. Now my n would become 1. Okay, it's 1 greater than 0, perfectly correct. And here my n would be 1, and here previously my fact is 120, so again 120 into 1 would be 120. And now my n would be 0, is 0 greater than 0, which is false, so it will exit the loop. So the output will be 120. Factor of 5 is 120. So my logic looks pretty good. I'm gonna now compile it and execute it. So gcc factorial output. I'll give fact. Oh my goodness, as usual every time I forget. Almost, if you had watched my previous C language videos as well, oftentimes I forget putting this stdio.h. okay, and again some issue. What's printf line number 18? What's the problem, man, with line number 18? Okay, typo, printf. Okay, now the compiler is happy, it's letting us to execute the program. So hack n, I'm gonna give 5, perfect. Now I'm gonna give 6, perfect. I can give like 3, it should be 6, perfect. But why the factorial of 0? It's coming as 0 because we are messing around with n, right? So what I can do is I can store an intermediate variable. I can call it as temp, or I can call it as user entered value equal to n, and then directly I can give here, because n we are manipulating, no? Obviously n is reaching 0, so obviously factorial of n is becoming 0. So we'll execute it, run it, it's 5, now it's coming perfectly fine. Okay, and 7, 5 zeros and 4, correct. 6, perfect. We have to solve this problem both recursive and non-recursive way, and here this is basically non-recursive way. And coming to recursion or recursive way is, first we need to know what is recursion. Recursion is nothing but a function calling itself. That's it, a function calling itself. For suppose there is a function called NerdyNani, and here I have a couple of statements, and in that itself, in that function itself, if I'm calling the function itself, that is NerdyNani, then this function is called as a recursion function or recursive function. So we are supposed to solve this factorial of a given number using recursion. But that what I'm going to do is I'm going to call it as factorial, and I'm going to pass it as integer, that is whatever the user actually enters here. I'm gonna call factorial of n, okay, whatever user actually enters, and I'm gonna finally, I'll call it as result, and I'll print the result. Okay, here I'm going to give n because this n, the n that is that we are going to manipulate here, will be different from this n. Again, I explained this in call by value and call by reference in functions video. I encourage you to watch that video if you did not watch yet. Okay, so here what I'm going to do is, so I have to call this function again, then only it will be qualified as a recursion. So we need to have a base statement wherein the recursion will actually stop. Otherwise the recursion will go on infinite number of times and you will be running out of stack. Okay, so for that we need to have a break statement or the base statement wherein the recursion actually breaks or stops there. So here in our case, if n equal to 1, what I can do is I'll return 1. So this is the statement wherein we are breaking our recursion. We'll try to debug once we are done writing the logic so that we'll understand it better. So what I'll do is I'll call it as, I'll take a variable called int result, and I'll call it as result, or simply I can call it as result equal to factorial of n minus 1 into n. That's it. So this is the recursive statement, and finally I'm gonna return result, and I'm catching this result here and printing the result here. So let's try to debug this and understand what exactly is happening. So first what happens, user, let's say user enters 5, so it goes here and the control executes or reaches line number 8, creates a variable result, and n is equal to 1. No, my n is equal to 5. So it will go to the else part, it will go to the else part, and there what I'm doing, again I'm calling this factorial function, but I'm calling with n minus 1, that is 4. Okay, n minus 1 into my I is basically my n is 5. Okay, so this the moment the control reaches here, factorial 4, again this function is called same thing. Okay, that is basically the recursion. So from here what happens is, again my factorial function is called, and my n will be how much? 4 this time. My n will be 4 this time, and my factorial, again I'll go to the else part, and my factorial would be 3 into my n is how much? 4. Okay, and again when the moment it reaches here, because factorial of n, right? So here it will be 3, and again n minus 1, it's gonna be 2. So we need to actually write like this. Okay, and it's gonna be 3, and again factorial 2 is called. So what I'm gonna do is, it's gonna be 2, it's gonna be 1, and it's gonna be 2. And again my n would be 1. Okay, and my factorial would be, I don't even reach the factorial, because this is a base statement, right? The moment I encounter 1, it will return 1. So finally factorial 1, I'll get 1 in the response. So 1 into 2 would be returned, that is nothing but 2. So factorial 2 here would be 2. So obviously I'll be having 2 into 3. So factorial 3 result, I have 6 here. So I'll be having 6 into 4. That is nothing but 24. So factorial 4, I have 24 now. 24 into 5. That is nothing but 120. 5 was 20. 1 will be carried. 5 to 10. 1. 5 is 10. It is 20, right? 2 will be carried. So obviously it is 120 is the answer. So it's better you debug like this, try to understand. So we will never reach line number 14 until and unless this entire recursion unwraps. Okay, it reached till factorial 1, it reached till this point, base point, and the recursion broke, and again it reverted like a wrapper. Okay, it actually reverted back and finally reached 120, and then it will reach the line number 14, and the result will be returned and is captured and will be printed. Let's try to execute it and see whether our logic is correct or not. So I'm gonna write gcc factorial. What happened? It's taking so much time. Okay. Oh, I'll call it as fact, and fact, enter the value 5, 120, perfect, and 4, perfect, and 3, 6, 7, 8, it's working fine. So it's like we can achieve the same logic, or I mean we can actually find the factorial of a number either non-recursive or recursive way. So whenever, remember that recursion means a function calling itself is called recursion. Thank you all for watching the video. If you like the video, please go ahead and hit the thumbs up button. Do like and share and subscribe to this channel.